7. Matt said I can go home a little bit slow after 7.
Hey guys.
Hey.
Hey.
Sorry, my computer was dying, so I had to take care of that.
You're fine. Oh, yeah. I'll be right back. Actually, I need to go get my charger.
Okay.
I'm good.
So my internet is being really slow tonight, so hopefully I can stay with you guys the entire time.
Hopefully we can do this fast. I've got it done by 7:45.
Okay. Yeah, I'm just trying to get my quiz to log in, and then I'm ready to go.
Yeah, I've got to log in real fast.
All right.
Okay. I'm in.
All right.
Okay, I'm ready as well.
Okay. Well, here's question 3 then. Find the margin of error for a 90% confidence interval when the standard deviation is 50 and n is 25. Round to 3 decimal places.
So
That one we put it into the normal probability applet for the area, right? Or
I'm trying.
confidence is X.
No, I totally wrote this down.
Right?
Um,
Yeah, so
There we go.
that's for 95%.
So the value that we would use, it has that table. It's like 1.645. But that's like the z-score or whatever that you use. But do we have to use that formula for this?
Um, confidence interval.
Is the
Margin of error.
what is that when you have the line over x minus 1.645, and then the confidence interval, or the 50 over the population?
Yes.
So we just need to know whatever that x with the line over it is. That, and then we can get our answer. Right?
Or would it be the margin of error? Well, yeah, margin of error formula.
I think that's the one we want to use. That was my question, is if that is the one we want to use. Yeah. Sorry, I just pulled up the summary thing again. So
Yeah.
it's the z times the standard deviation over the square root of n.
Yeah, so would you put 90 percentile in the normal probability applet for the area? And
Yeah, so the z that we use is 1.645.
Right, and you said that was times the 50 over 25.
Isn't
Yes.
that when you have 95 percent confidence interval?
95 is 1.960.
Oh, okay.
Yeah. There's like a little table somewhere in the chapter that lists.
I see it now.
It's in-
Yeah,
Okay.
so like the 90% and 99.
That
I got
makes it a lot
2.29,
easier.
is that right?
I'm still calculating.
What? Oh, there it goes. So, oh, God. I did. Okay, there it goes. Okay.
Did you get 16.45?
Okay, how did you do it again?
So, I don't know if you can see this. Basically, maybe you can't see it. Can you see that? I did this formula.
Okay.
So 1.645 times the standard deviation over the square root of n.
Because I did that same sort of thing this way. Let's see if I can get it up there. And that's what I got. I don't know if the parentheses messed it up.
It doesn't show that you did the square root of 25.
Oh,
the square root. That's where my problem was.
Yeah.
So,
I'll recalculate that.
Emily,
Yeah.
what did you get?
I got 16.45.
Yeah, that's what I got.
That's what I get when I remember the square root.
Okay. So on question 4, I think that it's the x is a point estimator of the u.
That was
There's
the
a-
one I was leaning towards.
Yeah, there's a table at the beginning of the chapter that lists all of those.
Okay.
I think that's
Yeah, I know, because the X is sample and the U thingy is population.
Right.
Okay, I can read the next question.
Okay.
Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a simple random sample size of 64 and computes a probability or whatever that is of 526. Use this information for the next 6 questions. So question 5 asks, what is the point estimate for the true GMAT score?
Would that be the 526?
I think so.
Yeah, that's what
Yeah.
my notes say.
Okay. There's some of these really easy questions. I'm like, wait, is it really that easy?
Yeah.
Right?
So what is the margin of error for the 95% confidence interval? So that's the same formula we just used with 1.96, right?
Yes.
Okay.
Okay.
Did you guys get 14.125?
Yeah. What do you get?
I got 14.125.
And that was taking the same one that we just used, the 1.96 times 113 over the square root of 64.
Yeah, I think that my phone messed up and it didn't times the 1.96. So this time I got 27.685.
Okay, that's the one I got.
Okay. Yeah, I think 14.125 is the 113 divided by the square root of 64.
Yeah, because I was like, my calculator on my computer, it showed me that answer, and then I pressed enter, and then it gave me this number. So I was like, I think that's what happened to you.
Does it say what we're supposed to round to with these? Nope.
No, this was annoying me on the test, too.
Right.
I assume it's 3 decimal places, right? It usually is.
Yeah.
Usually, yeah.
So the lower limit of this confidence interval, would we just use the normal probability applet and only highlight the lowest end?
I have no
So
clue.
this one, I think it goes because in the chapter it talks about the limits of the interval. I think what we do is
Is this the one where you do the minus? You would do the minus, not the plus. Would that give you the lower interval?
that's what I was thinking, yeah. So we take the number that we just got and do 526 minus that number.
That's going to be a really funky.
Hey, don't throw the watermelon. So it's you're saying it would be the 498 315 or
That's what I was thinking, yeah.
okay. Sounds good to me.
And then number 8 asks for the upper limit, so instead of minusing, we plus.
So I got 553.685.
That's what I got.
Yeah, that's what I got.
So would the
And
width of the confidence interval decrease if you increase the sample size?
so you increase the denominator, so you're going to get a smaller number. I think it would decrease, if I remember right.
Okay.
So what would it be?
I think it would be decrease because if you increase the sample size, which is the denominator, it makes the fraction even smaller.
Right.
Okay. Where did you read this in the chapter? 'Cause I just didn't remember anything about that.
It might have been in one of like the following question things.
Okay.
Let me look. Yeah, so one of the following questions is like, what would happen to the confidence interval if the sample size n was increased, but the other values were still the same? And the answer
Oh, that's
says
in section 5.1, question 16, right?
4.2, question 6.
Okay. Well, I was also saying 5.1 also discusses that thing, saying if we want to cut the margin of error, we have to
Oh yeah.
quadruple the sample size.
Yeah, I
All
remember
right,
that.
thanks, guys.
And then if you increase the confidence interval, it also increases the margin of error. Right?
Makes sense.
Yeah.
And then actually the next question on that same talks about changing from the confidence interval. Increasing the confidence level will lead to larger values of z. So if z is increased, then the margin of error would increase. This would lead to a wider confidence interval. So the next question.
So what do you?
Yes, that is what I'm understanding from that.
So z times O divided by M.
Yeah. But
So that's the one. Okay. I get 15.68.
What? What am I
Because you do
doing?
1.96 times the 400 divided by 50, right?
So it should be the square root of 50 again, shouldn't it?
no,
and then you times it by 2, then you square all of that.
yeah.
So that's where I'm going. Okay. 1.96 times 400 divided by 50 squared. So that would be 245.8624, so 246.
I'm getting like 110.874.
I'm getting 250, well, actually 245.8.
Yeah, if I did it right, I got the same as you with that.
Yeah, it looks like you did it the same way that I did.
Okay. Which that's the way I saw in the text, so I hope it's right.
So you guys
Yeah.
are getting 1.96 multiplied by 400 over the square root of 50.
No, just
square root.
50, no square root. And
And
then
then you
you
square
square it all at the end.
Why is it different? Why do we square it all at the end this time?
Because we're trying to find the sample size. So in a sense, think of it as you have the margin of error,
Oh, okay.
so you bring everything backwards to find what the sample size is.
Yeah,
Right.
I get it. I read the question. I didn't read the question.
I was gonna say that's also in 5.1 if you want to look back at it.
Yeah. That's my fault.
It's okay.
Okay, so what
Well-
did you guys get? Two.
So 245.8, but whenever you get a decimal, you need to round up. So the answer is 246.
Okay, we can move on, and I will go back and do that later because you guys need to do this in. So, okay.
Okay. So we're looking at the mean salary of actuaries is $100,000 and the standard deviation is 36,730. You're interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it's higher or lower. So you set up a hypothesis test with a level significance at the 0.05, and you have it that your HO and your HA, you collect a simple random sample of n equals 36 women. Salaries, find the X equals 111,000. So what is the lower limit of this 95% confident interval? And you're saying that'd be the 111,000 minus the margin of standard deviation?
If we did it right last time, it's asking the same thing, right?
Oh, so yeah, so it's the 100,000 minus the standard deviation divided by the square root of 36. Oh wait, we need the standard, the 1.96. So yeah.
I don't think that that's right.
What did you get?
I got like 104,000 something.
Oh. Yeah, I don't think that's right. What did you do?
I did it the right way. I think my phone is struggling today, though.
So that was the 1.96 times 36,730 divided by the square root of 36?
That number, and then you do the 100,000 minus that.
Okay.
Is at least what I did, and the way that we did it last time.
Well, I thought it was just the 111,000 that you calculated minus
Oh.
the margin of error of the 36,730.
Oh. Yeah, actually, I think you're all right. You do the
Which,
100.
if you do it that way, it'd be 74,27, 0.
Okay, let me.
If you just take the 111,000 minus the margin of error, or the standard deviation, I guess.
Oh, hold up. So it's 95%. So when you did it, did you do 2 times the standard deviation divided by the square root of n?
No.
Are you supposed
Because
to do
I have in my notes, yeah, because 2, I think so, because 2 is like, that's 95%, you know, it's like 2 standard deviations away or whatever.
Okay.
Is what's 95%. So I've written in my notes that it would be your x, so 111,000 plus or minus the margin of error, which next to that, I have that formula written, so I don't know.
Like, that makes sense, and like I did write that too, but like, when do you use 2 and when do you use 1.96?
That's what I'm confused about. This is a
Yeah.
lower limit question, though. Ugh.
So then maybe
Oh,
we
hold up, hold up.
I wonder.
I'm so confused because hmm.
Oh, I was just trying like both ways using 2 and using 1.6 gives you a different number. Dang it!
Yeah.
I was hoping it would be close enough that we could that it wouldn't matter.
Yeah, we could, like, I could try it one way and you could try it the other way and we could see.
Yeah.
That's what confuses me is, so in 4.2 it says that the formula that you're using is the formula, so that's the formula to compute the confidence interval for a mean where the standard deviation is known. So I don't really, like, we know the standard deviation, so I don't see why that would be wrong. I'm just trying to figure out where I got this other formula from.
Well, because I think at the beginning of the chapter, like, it says to use 2, but later on it says to use 1.96. So let me go up and see if I can find. Okay, so yeah. So at the beginning of 4, it says to use 2. And then
Yeah, I think that would be correct because I submitted the quiz using 1 and I got or the 1.96 and I got it wrong. So
Oh, really?
or whatever it was. I got everything right except the 12 and 13.
So, okay, yeah, I think you're right, Miranda, though, because up top it's saying that the formula where you use the z-score is more precise than the 2.
yeah.
Right.
But you got it wrong then, Jake?
Well, I just tried to do it the same way we did it for the earlier questions that were the same. Of what were the lower limits on the 90%
Yeah.
confidence interval, and I tried to follow that same formula, and I got it wrong doing it that way. So
Okay.
So then I guess it's the 2. So then did you get both questions, like both sets of questions wrong?
no, just 12 and 13. Like I said, I got the earlier ones right.
What?
So we did the earlier ones right, but
So I guess it's the 2.
I'm gonna hurry and do it the way that you did it, and then we'll compare numbers, because that could also be an issue, like just a calculation. You probably did it right, but
Yeah. So what did you get for the lower limit?
What I get for the lower limit?
Yeah.
I used 7427, which I think I should have actually used something more like the 11998 or whatever. I don't know.
So when I do like the lower limit, like and doing 1,000, not 111,000.
Yeah.
I get 99,001.
And go for that one. I think that's correct. Like I said, I think
You got 99,001.53.
Yeah, so actually that's rounded up to 2. Yeah, that's what I got.
Okay. So for the next one, did you get 122,998.46? Or 0.47, I guess.
that's what I got when I did the the margin of error and then did it.
Yeah, that's what I get.
Okay. Oh, hey, I know the answer to the next question. I totally wrote that down. So 14, it needs to be a simple random sample.
O needs to be known and X is normally distributed, right? So aren't they all correct?
Yeah, they're all correct.
Okay.
I got 14 out of 14.
Okay, well, so I just have to go back and enter it after having to add and subtract it after using the standard deviation and not instead of using the one provided. So there we go.
Okay,
Thanks.
cool. Thanks, guys. Are you all good to meet at 7 on Thursday?
Yeah.
Yep.
Okay, sweet. See ya.
See ya.
Yep.